Hello viewers, welcome to today's physics lesson. Today we are going to learn what is a photon. So the question for today is what is a photon, and we have four options. Option A, photon is a wave. Option B, photon is a particle. Option C, photon is both wave and particle. And the fourth option, option D, none of the above, and photon is something else altogether. And we answer the question what is photon from Young's double slit experiment. First of all, we need to understand the experiment apparatus of the Young's double slit experiment. We have a monochromatic source of light or a laser. We have a narrow single slit. After that, we have two narrow and closed slits, and this is the Young's double slit in the double slit experiment. And after that, we have a screen. Okay, now before going to the measurement experiment result or experiment observation, we need to understand what is interference. So interference is a phenomenon of wave. If a wave A and wave B are in phase, that is mountain of wave A and mountain of wave B coincide, and value of wave A coincide with value of wave B, then we have constructive interference, that is the two wave sums up and gives a higher intensity waves altogether. On the other hand, if the mountain of wave A coincide with the mountain of wave B, coincide with the value of wave B, and the value of wave A coincide with the mountain of wave B, then altogether they cancel each other and we observe no wave or a zero intensity wave. This kind of interference is known as destructive interference. Now, after performing the Young's double slit experiment, what we observe is interference fringes. We have a bright spot or bright fringe at the center. Then we have two more bright fringes on both sides. Then after a gap, we have another two bright fringes on both sides, and so on and so forth. And in between bright fringes, there are dark fringes. There on the both side of the center bright fringe, we have two dark fringe, then two bright fringe, then two dark fringe, then two bright fringe, and so on and so forth. And why this is happening? Look, consider the slit at the right hand side as slit at the, let's suppose that slit at the right hand side is emitting wave A, and the slit at the left hand side emitting wave B. Now at the center, the distance from the slit A or the right slit to this position, and the distance from the left slit to this position is same, and because of the same path length, same distance, both the waves from slit A and slit B reaches at this position, at the center position, in phase. That is, therefore they show constructive interference, and that is why we get a bright spot at the center. Now, just left to the bright fringe, there is a dark fringe. That means the distance from that point on the screen to the right slit and is more than the distance of that point from the left slit. And how much is the path difference? The path difference is actually equal to the half of the wavelength of the wave. Half of the wavelength of the wave. Half of the wavelength is this much. And because of that much distance, now the wave from the right slit and the wave from the left slit has a destructive interference, and we get zero intensity light, that is why there is a dark spot. And then again if we go further left, we have another bright fringe. Why? Now the path difference further increased to a full wavelength. So if the path difference is path difference is equal to a full wavelength, then after then they will again reach in phase, because now again further half wavelength difference will coincide a mountain with this next mountain and coincide this value with this next value. So we again has constructive interference after the first dark spot. So in this way, then again we shall have 1.5 wavelength difference, we shall have dark fringe. Then we have 2 wavelength difference, we shall have bright fringe. So this is the reason in the Young's double slit experiment this is what we are observing, and from this observation what we can conclude? We can conclude that the light traveling through this double slit experiment is actually a wave. So this is our first conclusion from the many photon interference experiment. Photon is a wave and option A is the correct option. So till now we can say this is the correct answer. Okay, fine. After that, we again perform the Young's double slit experiment by replacing the continuous photon source with a single photon source and updating the ordinary screen by a single photon detector. That is, now we are going to send one single photon through the double slit and observe what will happen. And this is a real experiment. We can perform single photon Young's double slit experiment in real laboratories, like there is an apparatus in IIT Delhi and also in Taiwan in National Central University I visited last year. There is an apparatus. So this is not a philosophical or thought experiment. This is a real experiment that we send a single photon through the double slit apparatus and detect it. What do we observe? We observe the no interference pattern and a single spot on the screen. Now this single photon passes through this slit, then one of these two slits, then it hit one single spot on the screen. So please note that a single wave may break into two components and interfere. Therefore, from this single photon Young's double slit experiment, we may conclude that photon is not a wave but it is a particle, and therefore option B is the correct option. Initially we think that option A was the correct answer. Now we think option B, photon is a particle, is the correct answer. Okay, now from the combining the observation of many photon Young's double slit experiment and single photon Young double slit experiment, we can safely conclude that without any further information that a photon is a particle or a wave based on the experiment or the observation. Therefore, option C is the correct option. Both these are true. Option C is the correct answer. Both A and B is true. Okay. Now here comes the final trick of today's lesson. In finally, if we run the Young double slit experiment with single photon for many times, let's say our single photon source generate a single photon in every 2 minutes, and in the first run of experiment the single photon hit this spot. Then in the second run of the experiment also the photon hit the same spot, but on the third run of the experiment, single photon Young double slit experiment, the photon hit this spot, a different spot. And say in the fourth run again hit this spot, and in the fifth run it hits this spot. So what is happening here? We are not touching the experiment, we are not touching the experiment apparatus in between those interval of two photons generated by the photon source, but they are hitting different positions in the screen. So what we observed is that after running the photon many times, in each run the photon hit at a single point on the screen, but the point on the screen may be different in different run of experiments. The probability of hitting the center bright spot of many photon interference experiment is the highest. That means if we run the experiment for long time, say for many hours, then most of the photon will hit this center position, then some photon will hit this position, some photon will hit this position, then a few photon will hit this position also, few photon this position. And if we run the experiment for long time, we will recreate the interference pattern of the many photon Young double slit experiment. Okay, and then the probability of hitting the second bright spot is a little bit low, and the probability of hitting the third bright spot on both sides is much more low, and so on and so forth. And also photon do not hit the dark spot of the interference fringe from the many photon Young double slit experiment. So what can we conclude after running the single photon experiment for many times is that photon is a particle that do not reveal its position before observation. Means before the photon hit the screen, we do not know what is its position, in which position the photon is going to hit. But we know the probability of the hitting position of the photon before observation, and the probability is the same if we send transverse wave through this double slit experiment. So means it is not a fully wave, it is not a fully deterministic classical particle. So what it is? So my conclusion is that photon is a probabilistic particle. What it is? It is a probabilistic particle. And in modern day, we call this probabilistic particle a quantum mechanical particle. Therefore, the final answer is that photon is not a wave, photon is not a particle. Obviously, photon is not both wave and particle. It is none of the above. Oh, this is the correct answer. It is none of the above. This is the correct answer. It is something else. And that something else is known as a quantum mechanical particle. So from today's lesson, we learned that photon is a probabilistic particle that we call a quantum mechanical particle. Thank you for your attention. Bye bye.